Right, well, thank you very much for the intro, Georgina. Would you mind just enabling my screen share so I
Yeah,
can bring that up? It should. Ah, no, it is enabled. Good stuff.
cool. And can we?
Right, just checking. Can everyone can hear and see my screen all right? Um,
Looks good to me, mate.
All right, good stuff. So, yeah, we're Touch Immersion, and we create really cutting-edge virtual reality programs, which are engineering tools designed to teach aerospace engineers and STEM graduates in a much more proficient and quicker method than current and traditional teaching and training methods. What we're introducing here is the skills for the immersive future. So how immersive technology really is a big future frontier, well, current frontier and going into the future. And to showcase some of the skills you need to go into it, if you so choose, and actually how easy it is to get started. So if I kick things off, I'm Tal, I'm the CEO and co-founder of Touch Immersion. I'm an aerospace engineer by training, got a BSc in aerospace technology with pilot studies from the University of Hertfordshire, and then an MSc in astronautics and space engineering from Cranfield. Effectively, Campbell and I kickstarted this company directly off the back of our masters, kind of late 2019, early 2020. And kind of the main motivation I have personally for doing this is we're targeted at STEM, so science, technology, engineering, mathematics, and mixing that with immersive technologies. And personally, STEM and engineering in particular is the real bedrock and foundation of human innovation. And learning and training is how you get new innovations, get new developments. So we've really got quite a powerful immersive tech tool here, combined with training and education that really has the global capacity to expand the rate of innovation across the globe. And it all starts with learning skills and training. And immersive technologies, particularly VR, is one of the best ways to do that because it allows you to learn quicker and more proficient than traditional methods. So that's a little bit about my background and main motivation of why I'm doing this. I'll now hand you over to Campbell.
So yeah, I'm Campbell. I'm the CTO and co-founder of Touch Immersion. But in effect, I'm very similar to Tao actually. I both have the same masters. We both studied the same, and we actually met at undergrad. Except Tao was in pilot studies, and I specialize with sort of a project management role and other management studies. But yeah, in effect, building what Tal said, I think VR now has or is at a stage where we can really use it to bring education to the next level. I've always been a big believer that engineering is fantastic and STEM general is awesome. But actually, when you go into some of the lessons, they are pretty boring. You're talking about engineering, you're talking about aircraft, you're talking about oil rigs, turbines, green energy, and then you just write a report on a piece of paper all day. Or you just watch a PowerPoint for 3 years, 4 years. And so it's just like, can't we do so much better? And I think VR now is at a point where we can really start, really visualizing assets that are very expensive, very hard to get to, a lot of health and safety requirement, and now bring those in to the classroom without such downsides.
So I'm going to run you through the kind of why and how we started TI, basically a very short illustrated history of where we started and to where we are now. And as I said, our main purpose is to accelerate global engineering developments. So the story so far, as you can see, I drew the short straw to have my ugly mug represent undergraduate studies. That's myself at graduation. So we originally came up with this idea during our undergraduate studies, kind of 2016-ish, and playing around with how virtual reality can be used. And the main motivation for this, as Campbell alluded to, was two main things. One, we wanted to get hands-on skills, but when you're dealing with jet engines, rocket engines, aircraft, it's not practical in terms of cost and just physical space to have all your undergrads actually playing around with hardware. It's just it's impractical. So we were looking at ways to actually get useful hands-on skills and not just becoming engineers who are good at writing reports and not actually doing anything. Virtual reality was obviously what we leaned towards, of going, well, hang on, if I can't have a physical jet engine, can I have a really detailed virtual one I can take apart, work with, design? And the second part is wanting to learn in a better way. And this is where you get the difference between active learning and passive learning. So passive learning is lectures, reading of textbooks, having someone talk to you and impart knowledge by speaking. Active learning is where you actually engage more of your body's sensors to physically do things. I think, we'll all agree your strongest memories are where you experienced something and actually took part in it. So that's precisely what you can do in virtual reality. You're engaging sight, sound, and touch, which is far more effective at creating memories and therefore having better knowledge retention than just by listening to a lecture or taking notes. So from our undergraduate studies, we then went on to do our masters 2019 to 2020. And off the back of that, we actually built our first product, which was a virtual reality spacecraft clean room for Cranfield University. And they actually liked it so much, they bought it from us and became our first client. And that's when, 2019, we really, into 2020, we really started rolling as a company and actually got set up and got moving. And yeah, then COVID hit. So the plan was we go for the MVP, we roll this out to a load of students on the course, get a lot of good data, go and say, hey, look, our program's absolutely awesome, and then build up from there. COVID shut everything down. So instead, we're software based. So we just went head down and developed, learned, built skills, and now we're in a situation where we're actually launching a virtual reality platform in about month and a half as a better way to retail our programs and get them into more universities and to more companies. So the current state we're at is we're going for an investment seed round later on this year, and basically working on scaling up to get more customers on board and to build our networks within the engineering and immersive technology spheres.
So if I bring it a little bit back to the code and sort of, obviously people here don't want to build a business perhaps, but want to use it for self-teaching. And actually, there are some real critical resources that we found when starting that were the best really. And they were main big drivers, such as cost, the difficulty, the flexibility, variety. So the first one's YouTube. YouTube is superb, really. I think the question on YouTube is really not what's there, it's what can you find, because there is so much, and it is an excellent amount of resources that you can really build on, from VR, AR, you name it, game engines, everything. It's got everything. And the next one we found was open source. So open source programs such as Unity or Blender, Unreal Engine, they are fantastic, but really what can make the massive difference is open source content as well, because you can reverse engineer. And a lot of these times, this open source programs, you can use them however you want, license free, which is superb and really effective. Another third one was Unreal Academy. So if you choose that Unreal Engine's for you, then this is literally as it sounds. It's a school that Epic Games have built for Unreal Engine. It has everything from whether or not you are a beginner, intermediate, or pro. It has thousands upon thousands of videos, and they are superb. They are fantastic. If I was starting again, I would start there. And then lastly, the good old forums. If you have a problem, someone's already had it before you, guaranteed. Again, like YouTube, though, it's whether or not you can find it, but definitely scouring Reddit. Unreal Engine has its own forums page, as well as Unity does. You will find some fantastic help on there. So looking at some of the skills that some of industry wants, well, for us, definitely, it basically splits it into three main parts. You've got your coding languages, you've got your visual scripting, and you've got your free animation softwares. So with your coding language, that's obviously your hard coding, C++, which UE4 uses, you've got C#, Unity, and you've got a bunch of others. And you can pretty much plug in, I think, all of these languages into any game engine you want, as long as there's a plugin for that. But these skills, I think, are becoming less relevant in terms of the actual hard code in large amounts, unless you want to be a dedicated programmer. If you want to be a dedicated programmer, then obviously you're going to need these skills. But visual scripting, this is where things are changing. So Tao and I almost exclusively build our programs in visual scripting because they are extremely powerful, and they're just practically, you can see the image, actually that's a visual scripting material for the algorithm. It's just a block of C++ code that you can connect inputs and outputs to. But these are fantastic ways to start as well. And in fact, most of the Unreal Academy videos will probably start, or at least stay with, for a majority, the visual scripting. So UE4 uses blueprints, Unity uses Bolt, and there's a whole host of others. And then lastly, something that if you do want to join sort of the STEM industry, and probably actually gaming industry as well, a lot of these are cross-compatible. You've got the animation softwares and the renderings, 3ds Max, Blender, Maya. We use CAD for our obvious engineering requirements, but they're extremely powerful tools as well.
So taking it from the technical side onto just the overall why is, we've talked about education and training, and that's a core reason, but why specifically to go into VR and AR? Well, 3 main points. One, you are effectively creating another digital plane of existence that, as far as your body is concerned, you exist in. So you have the complete freedom to create pretty much whatever you want. And don't know about you, but I think that's absolutely bloody awesome. So not only for the actual real world use cases, but just for the sheer experience and creativity that can be built using virtual and augmented reality. That's one of the main reasons to go into it. Secondarily, bring it towards education and training. Back to that, you can, as I said before, you allow people to get hands-on skills, virtual hands-on skills, where it otherwise would not be possible. And at no other time in human history have we been able to do this. This is a huge paradigm shift in the way people teach and train skills, everything from students to industry professionals. And with the availability of headsets, this is completely age independent. So don't care if you're 8 or 80, you can learn this. And lastly, particularly looking at the engineering side on industry in terms of design and development, you've got rapid prototyping now. You can do a complete mock-up of a system or a product. Here you can see a car that you want to build in AR or VR, test it, swap things out, change it, does it work, before you actually have to build the physical one. So that reduces the amount of time and costs it takes to bring new products to market, which increases the rate of innovation.
We look at some use cases, hopefully to inspire everyone towards them. You have to remember that virtual reality as a technology is coming to maturity, and AR is still a little bit away. So these use cases are primarily VR based because enterprises have seen and gone, well, AR's not quite there yet. But if we look at the first one, Volvo, they've really put some decent time and effort, and they saw the potential in this a long time ago. So you can actually see this is someone driving a real Volvo car down a real public road with a VR headset on. And they're digitally overlaying a brand new dashboard and sort of internal environment of the car over the existing one, so they can see how the new car they've designed is going to look, how the player or person would lean on the side of the window or play with the radio or activate cruise control. They can do all of that within the virtual environment, and obviously that's paying serious dividends to them. And that's all done with just a standard computer like one I've got next to me. You don't need a supercomputer. You just need a standard, fairly powerful, I will admit, but a standard computer. The next one, this one's an interesting one. So we don't have actually a picture of these, but again, it's another good example of a company using it. So you have Jaguar Land Rover. Now, they've been quite secretive with it. We know it exists. There's been snippets of news articles, but there's no pictures. And we definitely know it exists, and it's of high quality to something perhaps even better than Volvo's, because they were going to sell part of it to our undergraduate university. And then they blocked it for IP concerns internally. So they're basically worried the tech's not ready for public domain. It's too advanced. So it's a really good example, and you can really see that if this is what you want to go to, speaking to these companies or doing research on them would unearth potential sort of skills to grab their attention. If we then look at some like aviation examples, for example, you've got Lufthansa Cargo. Now they're using an AR one. This is an AR example, but they use AR to train their cargo engineers to strap down certain loads that are sort of precious or high value. So cars, wind turbines, they can be jet engines, things that are dangerous and expensive to do in real life, so it needs to be done properly. And they've reported great success. Now, interesting enough, again, if you wanted to go down more an AR route, is that Lufthansa have picked AR, we think, because more of a point towards that they want to get familiar with the technology before it comes around. Their use case does actually look at. And lastly was Delta Airways. They use it for their ramp engineers at airports. We were lucky enough to meet the director for training for Delta Airways at a conference. And again, he has expressed phenomenal results from their training in this, and they love it. Unfortunately, Corona's put things on a bit of a pause for obvious reasons, but he was saying that once everything gets back to normal, 100% VR's back in the game. Now, this one's an interesting one as well because it's not directly rated, but VR is more of a plug-in to this. So in essence, a digital twin, if we take the jet engine as an example, is something that you design as you do today, you develop as you do today, you then build a prototype, you test it, and then from that data, you can create a completely virtual model. And effectively, it's sort of what Volvo are doing. So you plug in then VR to that, and you can sort of see an outline. But this is currently being used in the oil industry, wind turbines, jet engines, for example, the really highly expensive assets. But the new game changer, if we see the next one, is the US military. So if they have done what they said, which is they have completely created a digital fighter jet, tested it digitally, and then created a prototype, which is effectively the finished product. So you no longer have to build any prototypes at all. You can go straight from computer to completely finished product, all digitally. Then VR will bolt into this even more critically. It's the intangibles that you cannot get from ones and zeros, such as cockpit layouts or maintenance procedures, that VR will really bolt into this so effectively that actually this is definitely a very interesting career path, and it's something that we are going to be watching massively.
You want to talk quickly about the timescales and costs that was saved with the digital twinning?
Yeah, exactly. So this will become more prominent over time as well. So for example, the 5th generation fighter jet, for example, took, or the F-35, if you know the one I'm talking about, took 20 years to develop and 1.7 trillion US dollars to develop. Now the US military have now done this in about a year to a year and a half. So they've shaved 18 and a half years off. And whilst the cost is not public yet, I'm sure it's probably in the hundreds of billions. That's not 1.7 trillion. That's not, half of the UK's GDP. So there's some absolutely amazing gains that they made, if they are exactly what they say, because at the moment, obviously, everything's slapped with the classified. But this will become more prominent. If this is, as I say, what they've said, this will become extremely predominant throughout the market for literally everything: cars, planes, trains, you name it. This will be the next big design platform. Now, if we take a step back and really look at what we would have done differently if we were starting again, so then straight away we would have studied a bit more of the basics. I think a mistake we made is we tried to jump into coding too early. I would definitely go away, look at the tutorials, understand your platform, understand how it flows, understand the language a little bit as well. If you're going to go more down the visual scripting, for example, we do in UE4, I would then really look up C++ because I think that's helped us a lot. Because you can understand what those inputs want. You can understand what it can do. You understand the functions available to you. I think we jumped in a bit too quickly. We could have spent more time learning the basics. I would then also reach out and build a team sooner. So obviously for us as more of a business team, but for people who want to study, a bit like what Lola had, go and study together. You can build a team of friends. You can learn so much more, overcome so much more as a team. I think as a team, you'll progress together so much quicker than just an individual. That I think is definitely a big point. Thirdly, set up version controls. If you're doing any sort of software, set up a version control. Sorry. Set up a source control. So in UE4, it's called source control. So set that up, because I almost guarantee you will delete your work by accident. It just happens. You delete some code, it deletes something else, and then before you know it, half it's not working or broken or deleted. So definitely set up. And then lastly, something that we've implemented recently, focus on one task at a time. So obviously you'll have loads of tasks you need to complete in the program, but do them in big blocks. So at the beginning, we started splitting our time up into little chunks so we could then work on multiple areas and progress a program. But actually, we found that's not terribly helpful because you get out of the zone. Really spend your time on large tasks. So for example, tomorrow I have an 8-hour session on a certain work package I need to do. It's just bang, done. And that I feel is much more useful. You really get in the zone, you understand your problem, you stay productive for longer, and you can finish it rather than splitting your time up.
So looking at the future and how things are going to evolve. So primarily the STEM industry, more industries are hiring across STEM, and there is a need for more software skilled people. If it's not so much a question of, what technology do I pick that gives me the greatest job opportunity? It's pick one you like. There will be jobs available. There is a use case for it, particularly with software skills, and particularly on our side with virtual and augmented reality. You're not going to be out of a job, don't worry. Looking at the actual future use cases as far as the impact that immersive tech is going to have, well, in terms of what industries you could go into, there's immersive gaming. It's already revolutionizing the entertainment industry, and that's going to only become bigger. So if you've got a knack for wanting to go, I want to see how I can better entertain people with gaming, with AR tech, go into this. XR based learning and teaching, with what we're developing, you're going to have augmented reality and virtual reality learning suites in universities in the next 3 to 5 years if we have our way. And we're not the only ones working on this. So this is going to be a huge paradigm shift in learning and teaching. So if you've got a knack for education and want to do that, you want to go this way. And as we mentioned before, with digital twinning and just VR training in general, revolution industry design and development. Again, the next, we're already seeing it now, the next 5-10 years, it's going to completely shift how new products are created in ways that we can't actually conceive of. We've got some ideas, but the reality is nobody actually knows. We just know it's damn exciting and it's going to be absolutely world-changing. With regards to how you can get involved, well, we've put together just a resources one-pager with links to some of the main resources that we used to learn virtual reality. Some of the main game engines. You can see YouTube there. Got the 4 main channels that really helped us. Links to the game engines, link to some open source software, as well as some forums and academies. So I don't know if Georgina's putting that in the chat or is going to send that out to you by email later, but take advantage of these resources. They're really damn useful. And stay up to date with our progress. And yeah, that's basically it. In terms of contacting either myself or Campbell, we've got our email there. And Also, there is a QR code which you can scan on screen now to get access to that one pager as well. So I'll just now open up to the floor for a bit of a Q&A session. If anyone's got any burning questions or just general comments. Thank you for your time.
Brilliant. Thank you so much, Tao and Campbell. There's so much there that learning, and as I say, rules are needed. There's jobs there. There's a lot of investment, but it's brilliant that you've helped us sort of where you've come from as well. Just one of my questions that I and I'll look at the chat as well, but very quickly, how long did it take you to kind of produce something, you know, that MVP, to kind of just so you could show something?
In terms of a kind of basic version, so effectively, if you run it from, we graduated September 2019, we actually set up in Cubic kind of mid-September, and it was basically myself and Campbell sitting down in front of a computer going, do you know how to code? No. Do you know how to code? No. Okay. It was kind of a situation of we can design satellites and spacecraft, but we didn't know a single line of coding. So we went to these basics, and it was actually pretty quick. From getting the basic idea of, okay, this is how Unreal works, this is visual scripting, to kind of a first workable model was probably about 3 months.
And I think you can even cut that in, or you can cut that to almost nothing if you want to create something yourself and you're willing to use a model that you can just find online, and perhaps someone's already done it. You can probably do it in an hour to 2 hours if you have everything you need. If you need to mix it up a little bit, yeah, all you've got to do is really learn a few of the basics, and you have time to, even if it's just Googling how to do something.
Yeah, and we're just on the subject of the basics. The reason why we probably should have studied quicker. We literally did a 4-hour Unreal Engine 4 tutorial and then went, okay, yeah, let's now go and do it. And although we do operate on a very aggressive manner with learn something and then learn the rest of it by doing, probably could have spent, you know, maybe 10 hours going through a few of the basics. Would have saved us a lot of gray hairs later on down the line. But effectively, yeah, from knowing nothing to having an operational VR program that we could show off and then, you know, got paid for, was 3 months. Working full time, I might add.
And that's it. It's not just the coding. I love the way that you say it's the sort of the visual editing, so you don't have to learn the code. It's just drag and drop and connections. There is so much more I want to obviously ask, but I obviously can, you know, if anybody wants to know some more, and I'm sure we're going to you know, keep working together, and obviously I look forward to seeing about your platform that's coming out, and good luck with your fund raising that you're doing and your seed investment. So good luck for that, and thank you for coming along today. So I really appreciate it.
Oh, thank you for having us.